Hey, it's nice to see you actually.
Yeah, hi. Website.
Yeah, this is just just to say that I have actually uploaded today lecture slides to the website, so everybody can take a look and walk them through in their own pace, because I realized that I may be too slow, too fast. So if you want to look at the slides in your own pace, then you're absolutely welcome. There is also a link to the collab that we are going to use today. I know that you guys had collab in deep learning course, so it shouldn't be new stuff. Yeah, but pretty much everything I'm going to show step by step, so it shouldn't be a problem. Let's wait for maybe a couple of students. I don't know if they come. I still have hopes that we'll have more than you. Somebody else will join as well. So, but before that, I just wanted to ask, so what's your interests? What are the most interesting, juicy things that you liked from lectures so far? What are the topics that you yourself like very much?
You mean in this course, in this particular course, or in general?
Well, maybe something related to machine learning, data science, machine learning.
Yeah, in fact, we had a very interesting course on statistics. So yeah, just statistics. We used R mainly, hypothesis testing, etc. Okay, samples versus population. So all the basic things were explained. Yeah.
Okay.
After that, another interesting course was, of course, Roman Ko's course. Very wide.
Hey, Oleg.
Very wide. Sorry?
Yeah. Oh, I just had a couple of your colleagues joining.
Hello.
Hi.
Hello.
I watched.
Hi, everyone.
Hey. Yes. I watched the deep learning course, and I really remembered this background, Oleg's background, the pictures there and this colorful frames. I watched a couple of lectures, so now it's super important. So super cool to see it. And also, I like, Simon, your background. You have these plates on the wall. They look pretty cool.
Enjoy.
Yeah, Kenneth. Hi. Morning. How are you doing today? Hey, you also have a great background. This is pretty cool. We can't hear you. You're muted, I guess.
Muted.
Thank you very much. Thank you.
Hey, cool. Cool to see. Nice to see you. I almost met you guys because I watched the videos from deep learning course, and I'm like, oh, these are my favorite film, stars. I met them before, and now they finally talking to me. This is so cool. All right. So morning, everybody. Welcome to the advanced machine learning course. I really don't like the name advanced machine learning course. So this is going to be a machine learning course, but it would be an equalizer course. So I would basically position the course as an equalizer course. We'll see what you know about stuff and what you don't know about stuff, and what are the topics that you are excited about, and what are the topics that you may be a bit less excited about. So I think it's the right time to start. We have 4 of you. That is what I expected, because Lena is taking the course, but she's in Canada, so it's 2 a.m. in Toronto. So I would expect that she wouldn't join. So let me share my screen, my slides. I have 2 presentations today. One is called organizational information. So can you guys see my screen?
Yes.
Great. Right. So basically, I send a link to chat. This is a link to the website, right? To the course webpage, the Moodle stuff. And you can find this presentation and the next presentation and the presentation after the next presentation on the website. And you will also find a link to Collaboratory. So today's Collaboratory, we will have 1 Collaboratory per lecture. And I'll tell you a bit more about this in a second. So first couple of words about myself. Who am I and why am I thinking that I can tell you anything about machine learning? My name is Dmitro. My surname is Fishman. I'm happy if you call me Dima. So that would be my happy name. You can call me Dmitro, whatever you like, but my short name is Dima. My email is here. I'll put it everywhere so you will know it by the end of the course. I have graduated from National Technical University in Ukraine. I have then moved on to get my master degree at University of Tartu. This is Estonia. And I also got a sandwich. So there was a double degree with Stalin Technical University. So my master degree has been between two universities. I also had an exchange semester at KTH, which is Karolinska Technica Högskolan, or Royal Institute of Technology in Sweden, in Stockholm. And now I'm a PhD candidate at University of Tartu. Hopefully this would be my last year of being a PhD candidate. So hopefully I'll have this magical 2 letters in front of my name, but so far I'm just a PhD candidate. I am an assistant of data science. So I do teach data science at University of Tartu, and I also research. I do research in the area of machine learning at University of Tartu. I have been an instructor of machine learning course at UCU, which is Ukrainian Catholic University. It just finished like a week ago. Now I start at KC, so Kyiv School of Economics, instructor of advanced machine learning. Again, I don't think it's a perfect name. I think it's machine learning, maybe a bit deeper in some ways, but not too deep. Okay. So what am I saying? Tartu, I meant this place. So this is a small town at the north of Europe. You can see this is Ukraine, this is Estonia, and here's Tartu here. Usually called the city of good thoughts. Also elected capital of culture, European capital of culture in 2024. So if you come by, please drop me a message. I usually love to walk my students, ex or current students through the city. I would be absolutely delighted to see you guys there. A couple of things about what I do in Tartu. I'm part of the Bioinformatics Information Technology Research Group. So this is what I do as a researcher. So if I put my research hat on, this would be the things that I do. I analyze, well, I'm one of the crazy people who analyze biological data using computer science. So this is what we do. We use data science, we use machine learning, we use computer science to analyze and help to make sense of biological and medical data for medical people. I'm also doing this computer vision. So you had just a course on deep learning in CV, right, in computer vision. So basically what I do is I analyze microscope images. So we get these microscopes that make images of cells, and then we run deep learning algorithms to look for these cells. And then we characterize these cells. So we're saying how big they are, how smooth they are, what's the texture of these cells, and that kind of things. Okay, so this is in collaboration with a company called PerkinElmer. These are the things we do. I'm also considering myself to be of the crazy kind. So we crazy people love to do some crazy stuff, like, for example, autonomous driving, right? So this was a project that was started between University of Tartu and Bolt company. This is a collaboration. So we collaborate with Bolt to research autonomous driving capacities for Europe. Well, specifically Estonia. So we have this autonomous driving lab, which is a car, which has this LiDAR on top. It has radar, it has drive-by-wire mode. So the drive-by-wire mode is when you basically can program car to go with a specific speed and with a specific trajectory, right? So you're saying, hey, car, could you go, you know, front and then turn left and then turn right and that kind of stuff. And the car has to build the safest trajectory to meet your requirements. So this is about this autonomous driving lab. It's a collaboration between University of Tartu and Bolt. And this is me driving the car using joystick, right? So basically, this is what drive-by-wire mode actually does is when you take some kind of programmable environment and you create set of commands for a car to set. And for example, you can use joystick to control the car. And of course, awesome you, right? So this is I talked a little bit about myself, so I just wanted to ask you a couple of questions, like what is your name? What's your background? Why do you take this course? I know this course is elective. It would be nice to know what's your expectations. So what do you expect to get from this course? Simeon, can we start with you? Because I already talked to you a little bit, so you shouldn't be afraid of me anymore. You can say a couple of words about yourself.
Yeah, hello. So my background is mainly in finance and in data analysis for business. I came to IT in general to systemize my knowledge around the data analysis, to see the modern techniques for data analysis and to remind statistics, math, etc. And this particular course, I take due to the name of the course, machine learning and time series modeling. So I believe that this knowledge will help me to.
Sounds pretty sexy, right? That's what you should say. It's like, this is so sexy. Awesome. Absolutely. Yeah. All right. Thank you very much. I think, so let's see if that the name of the course will actually suffice to make you happy about the course. But I'll give my best shot. Trust me, I'll give my best shot. Kenneth, can I ask you the same question? What's your background? Why do you take this course?
I have a degree in economics from the 90s, and I own a business in British Columbia. And my business collects a lot of data, and I'm kind of interested in what might be able to be done with it. Taking courses at KSE because I'm in Kiev for 3 years, and I thought it'd be a good way to meet people and study something interesting. COVID has gotten rid of the meet people part, so I'm just in the house instead. And why this course? While taking other courses, professors hint at how time series is something special and particular, and time series seems to be where all the solutions to the problems I find interesting exist. So time series was what attracted me to this course.
All right. All right. So I have to break you a bad news. I'm not a specialist in time series. I will try to become one for the lecture, but I am definitely not the most experienced person. But what I can promise you is that I'll give my best shot to prepare as much as I'll find useful for a time series. I did some analysis with a time series, but it was a long time ago. So I wouldn't expect too much from that, but I'll definitely give my best shot on time series as well, because I also want to know more about time series, and that's the best way to learn, is to prepare a very good lecture about time series. But I'm a supervised learning person. So I do a lot of supervised learning. So I haven't done much of the times. I mean, it's still supervised learning because this is a regression problem, but anyway, I'll give my best shot. But I just want to set the expectations at the right level so that if I over jump your expectations, you'll be happy. If I at least match your expectations, that should be fine. So I'll just trying to tell you ahead that I have been taking, I guess my role in this course has been because of my other lectures from supervised learning rather than time series, but I'll give my best shot. Oleg, can you say a couple of words about yourself?
Yes, hello. My name is Oleg Moroka. My background actually, I work for about 10 years in software development company. Yeah. Let's say mainly we make software development as an outsourcing service, yeah, for our foreign customers, and we have one main customer which works in automobile industry. That's why this autonomous car driving is also, let's say, now interesting to me. So I started like an engineer. So now I have this management role, yeah, in the company, and let's say my motivation was also to understand the power and business applications of data science, yeah, and try to also to propose the service to our customers, plus to think about some maybe product development, yeah, because I still think that there is a big future for this, yeah, opportunities. And why I selected this course in particular, because I wanted to follow a technical track, yeah. So let's say on one hand there was no choice, yeah. On the other hand, let's say, yeah, it's in any case, yes, this machine learning and time series. This is where I would like also to understand it's better, yeah, to go deeper, yeah, from different angles, yeah. Maybe if it will be even repeated, then to fix it in the mind somehow, yeah.
All right.
So
yeah.
let's.
Yeah. Thank you. So actually, I this is something I wanted to say, that I will provide you another perspective. So it's not necessarily something new, but it's definitely from a different point of view. So you could try to build up a more robust representation of whatever methods that me or some other people before me told you about stuff. So I'm happy that this course is taking place exactly because it will be an equalizer for many of you to bring you all to the same page. Thank you very much. I wanted to say, I kind of expected somebody to say that there was no choice. So I took this course because there was no choice. So you are the first one. Tick. Igor, can you say a couple of words about yourself?
Well, of course, my name is Igor, and my background is mainly in finance and economics for large Ukrainian companies. Well, why this course? Several reasons, because it's fashionable and sexy and so on. Second reason is this course was well advertised by Mr. Romanko. All those words like time series and deep machine learning and advanced and whatever. And the third reason is that, well, I'm really not the guy from IT and with no special programming background, but I had to put myself into some kind of a challenge. Yeah, so this course is a challenge for me. Just everyone could easily speak words like machine learning and whatever it is.
AI.
But I would like AI, but I would like to have something behind these words. I would like to have some understanding what is in reality.
What is there? What is behind the curtain that says AI and machine learning? Thank you very much.
Like
this is actually a very, I think it's something that I aimed from the other side. So if you're aiming as a student at that place, figuring out what is there behind these words like machine learning and AI and that kind of stuff, this is where I aim as a teacher, as a lecturer. My aim is to explain what is there. How does it look like on the other side? And I really want you guys to try it yourself with your bare hands, do all this kind of AI and machine learning and see what is it actually about. I saw the other lectures. I know that I'm recorded right now, so I won't say anything nice or bad or whatever other advertisements or other courses, but I feel like this course has a very different way of approaching the teaching problem. So I hope that you will learn something useful from here. Right, so before we actually start, I wanted to give you a couple of things about the way how this course will be organized. So how are we going to run this course? We are going to have modules and practices. So we're going to have lectures and practice sessions. I have a practice session embedded inside the lecture. You will see how it works. So we'll basically go through some slides, and then I'll say, let's switch to the collaboratory. And I know that you guys had collaboratory, so you shouldn't be too surprised about collaboratory. And then we will go back to the lecture slides, and then we will again move to collaboratory and so on and so forth. There will be, so I don't have it right here on this slide, but there will be 4 homeworks. The entire course will consist of lectures, practice session, and 4 homeworks. 4 homeworks are basically embedded inside practice sessions, and I'll show you today how does it look like. There will be hard deadlines for each of the homework submissions, but we're all grown-ups, and you have, you know, maybe you have kids, you have job, and you know, all that kind of stuff. So there are 7 late days in total. So each one of you have 7 late days. So sometimes you can skip the deadline and submit later to use the budget of your late days. So for example, if you have submitted the first homework 2 days late and the third homework 3 days late, you have used up 5 days of your late days budget, right? And in total, you have 7 late days to submit work without penalties. After this, there will be a penalty for each extra day that you submitted late. But otherwise, I'm trying to make sure that the deadlines are feasible and reasonable, and I can discuss that with you as well. And there will be no final test. Okay, there will be no final test, just 4 homeworks, 25 points each homework, and no final test. This is my preliminary syllabus, and I will explain why am I saying preliminary. So first of all, I wanted to do the equalizer lecture about supervised learning. I know that you had deep learning, you had this introduction to data science and AI courses, and you probably know bits and pieces about all of these things. But exactly the idea was to equalize, to bring everybody up to the same speed, up to the same page, and really talk about these basic things to make sure that everything fits into your guys' minds. Then I thought, so this is where I'm undecided. So this is where I'm undecided because I just had yesterday a conversation with Roman Ko, and we were discussing this, and we are unsure. I have a couple of things. I have a couple of lectures ready, and I'm actually willing and I'm hoping to give you as much as possible, but the time is limited. So we need to make sure that we give you the best and the most important information that you may need. And this could be unsupervised learning or regularization methods or deep learning. And I hope to find out this by the end of today. Actually ask maybe you and see what do you think about this, and then we could decide. So far, I have been thinking about regularization methods. I just want to explain it really plainly what the hell regularization it means, right? What is regularization? What the hell, and what is it useful for? On 29th of May, we will start with ensemble methods. So this is where advanced machine learning name comes handy, because this is where we're going to do advanced machine learning, but not too advanced. So don't be intimidated. It's going to be fine. And then the last lecture will be about time series. So I'll be basically diving deep into time series and seeing how you guys respond to this. Do you have questions? By the way, ask me questions at any moment of time when you feel you're losing me, you don't really understand what's happening. Please stop me and say, hey, what the hell is this? I am judging the quality of my lecture by the number of questions I got. So the higher number of questions I got, the better the lecture. So please ask me questions. It is raising my mood and my confidence and all that kind of stuff. So please ask me questions. All right, so just to repeat, there are 100 points in total, 4 homeworks, 25 points each, and there will be plenty of bonus points available. So you can actually get more than 100 points by the end of the course, okay? No exam, no paper, no project, just 4 homeworks, complete them on time, submit, And here you go. You can get your A, B, whatever. If you care about the grade, then it's not a problem. These are the deadlines. So today I plan to release a homework number 1, and that will be, the deadline will be in 2 weeks' time. Homework number 2 will be released tomorrow as soon as I know what the topic we're going to dive into, and the deadline will be in 3 weeks' time. And 3 weeks because I know that you guys will be busy with the first homework, so you need another spare week to attend to the second homework. And then on May 29th, I will release a homework number 3, which will have again 2 weeks from the release, and then a homework number 4 will have 3 weeks. Sorry, 3 weeks to deal with. So that is the schedule. I will show you that homeworks are not hard. They're maybe a little bit volumetric, so there will be a lot of things, but you'll definitely see it's not hard. It's just that you need to take some time off. I have just run this course or similar course in UCU, and people were reporting like several hours per homework. So I don't think it should take you too much time. Do you guys have questions about the deadlines? These are official, so they will be on the webpage, sticking around, and you can find them. I will also, as soon as I open homeworks, assignments on Moodle, you will see what's the deadline. So all these will be on Moodle, okay? And actually, these presentation slides are on the Moodle already, so you can find them in Moodle. Yeah, so course webpage, you all know where to find it. Unfortunately, there is no forum per se. So this is something that I don't really like myself. I would love to have some kind of Slack channel or something where I can just chat with you and, you know, drop emails or messages, just say how are you doing and that kind of stuff. But it's not really there. So what I'm going to use email or Moodle. So there is in Moodle, I can send email to participants. This is probably the way how I'm going to approach this. There are 4 homeworks. There will be general feedback from me. So I'll actually read every one of your homeworks, and I'll write to you a couple of sentences saying, hey, this been a good homework. I guess you could have done here this, or it's all right, or that kind of stuff. So I'll be basically trying to give you feedback. I'll show you how do we deal with homeworks. You need to export your IPython notebook file from your collab and submit it to the homework, sorry, to the web page. So that would be, that's all, the whole thing. You just extract the IPython notebook and then you submit it to web page. Nothing else. So the file just goes to the web page and that's it. Code of conduct, I couldn't have missed that slide. So we are valuing the involvement of every one of you and myself and the organizers. So we are committed to creating friendly and respectful atmosphere, place for learning. So we encourage every participant, including lecturers and organizers, to treat everybody with respect and courtesy. So I really, guys, I really hope that this not be a problem here. Obviously, plagiarism is not tolerated. Again, you are not my bachelor students. I don't think there is any need to kind of emphasize this. You know it better than I do. There was another idea. I had an idea about elective lecture, right? So I'm teaching and giving talks about many subjects. So this machine learning is not the only thing that I teach, is not the only thing that I talk about. And I'm usually in my courses, I'm open to give an elective lecture based on students' interests and students' kind of common interests. So there are some lectures that are available. For example, I'm giving talks about autonomous driving, about bioinformatics and medicine, about microscopy images analysis, about Gaussian processes, about deep learning, about some of the machine learning. And you can find all these presentations in my SlideShare. You can look through them. And then if we have time, you can tell me, hey, we really want to have a lecture about autonomous driving. And then I can give you a talk about autonomous driving, what we have been up to in Tartu. And so that would be a way to go about this. Any questions so far? Okay, good.
You said, Dima, you said that you send link.
Yeah,
It's the same, yeah, what we see in the Moodle, yeah?
yeah, basically these are the same things, absolutely.
Okay, it's just course page on the Moodle. Okay, and maybe one more reason why we all selected this course, yeah? It's also regarding the correlation and causation. It seems like all participants of this course are men with a bed, yeah?
No, it's also we have a student in Canada. She's a girl. She's not going to participate online, but she's definitely going to watch this, and she will be like, "What Alek are you saying right now?" Because I don't have beard, so how is that correlation?
At least small one, yes.
She's an outlier. She's an outlier, but it's actually a pity. I think you had another girl, right, in some other courses, but she obviously did not select this course.
Alina, yeah.
Yeah. I remember she has been a participant of this deep learning course. Kenneth, did you say that the link didn't work for you?
Well, because there's no permanence in the chat in Zoom,
Yeah.
No links that you posted before I joined are available to me.
Oh, sorry. All right, you joined after I sent it out. Sorry for that. But this is just a Moodle. This is a page for the course in Moodle. And basically, let me show you the Moodle, the course page, just to kind of be.
Yeah. So I looked there, and you need to give us permission to link to the code.
So the code link does not. This was intentional. So you should create a copy. So let me show you this. Here we go. So this is the first collaboratory, right? What you should do, you should click on File and then save a copy in Drive.
No, you need to give us permission to view that. If I click the link, it asks for permission.
Oh, okay. So you're saying that it's even the link is not.
Yeah, it's sharing status.
Gotcha. Sorry for that. Absolutely, that makes sense.
And while we're talking about this stuff, Slack would work for me. I like the idea of having a chat that would last between sessions, I think.
So now you guys should be able to open the this link, right? Yeah, you should be able to open the collaboratory right now. I'm sorry for this. This was not intended. You shouldn't be able to change the code. This is important. You shouldn't be able to change the code, but you should be able to view the file. And then you should be able to click on Save a Copy in Drive, and that will make a copy which you can edit, and which is important because this would be your homework, okay? I'll let me send the link to to chat. Exactly, Kenneth. I'm all for it, but this is something that I asked from the organizers, and they seem not to have that kind of thing. So in UCU, we had the Slack, which was meant for the program, for the entire program. We had the Slack for my course and for other courses, but in KC, I don't think they have a Slack.
But I have Slack. Semen, you said you have Slack works for you as well. Oleg, are you a Slack person already?
Not, but I think it's not a problem, yeah, to use it. Yeah. So for me, it would be good, yeah, to try it.
Otherwise, I would be happy to join in. I mean, we can create an empty. I can create for you guys an empty Slack. So if you wouldn't mind, I can create a new channel that would be like just specifically for our course. We are like 1, 2, 3, 4. I mean, that shouldn't be easy. It should be very easy. So this is a homework. So this would be my homework, okay? I'll create a Slack and I'll just share it with you. All right, so this is the collaborator for today, but let's not get through it first. I'm going to switch back to my slides, to my keynote. Yeah.
And when we shall, let's say, to vote for some this additional lecture, either for autonomous driving or for
so as soon as we have Slack, I'll make a voting for you guys, a voting message.
Okay.
You can vote for lectures that you like. All right. Does that make
Okay.
sense? So I'll
Can we
just
select two options?
yeah, you can select as many as you like. It's just the one that has the most number of votes wins. So so
Okay.
you can vote for every lecture, but that wouldn't add enough entropy to the voting process. So yeah, just go ahead. Go ahead. Yeah, so this is the first lecture on supervised learning. And that lecture has a very specific purpose. As I was saying, it's basically my attempt to level up the differences in your backgrounds and bring you all up to the same page, all right? I have to warn you about something. I'm very annoying lecturer, right? In a sense that I actually ask very many questions from my students, and I really want my students to participate. Not that I want students to participate, I want students to understand. And for students to understand, it means to basically be in my flow in the lecture. So please forgive me if I will be bothering you with questions and saying, hey, could you please help me with that problem here? Sometimes I'm asking very simple questions that may sound humiliating. Please forgive me for that. There is nothing that I consider to be obvious. So if I'm asking obvious questions, that maybe this is because they are obvious, and I just want to know that you understand that they are obvious. So let's just go through these slides and see how it goes. Okay. Couple of visionary slides. I don't like visionary slides, but I still have visionary slides. I see some and you're impressed, but so basically this is just a visionary slide saying AI is cool. Basically there are a couple of slides in my lecture here that say AI and machine learning is cool, and it's nice to be in AI and machine learning right now, right? It's actually, so it's still peaking. So it's not really getting down. So it's a nice time to be in AI. And these are the 100 startups that the most influential startups of the previous year. I myself know this Mapillary company, which has mapped the entire, so they use the Google Maps to actually create a map of traffic lights. So you know where exactly the traffic lights are based on the Google Maps, which was pretty cool and useful for the people that do autonomous driving. Momenta has been also working on autonomous driving. I honestly don't know other startups. I think I've heard about Butterfly Network, but not enough. And I guess this is not an exhaustive list of startups. These are just the ones selected by some journal or some web page. Then sometimes I'm asked this question, so you're working with deep learning, right? How is this deep learning has, changed anything in our real lives? Did it actually make any difference? And I usually point people to this website called Deep Index. So you can guys go ahead and check it out yourself. I think it's very useful because it has this tons of pretty cool examples where deep learning has made a difference. And basically you can see how drastic the difference is. And it's a lot of names, it's a lot of things where deep learning has helped us to make a difference, and you can check them out. Well, a couple of examples from myself. There's something that I'm something very close to my heart. For example, AlphaStar, AlphaZero. It's a computer algorithm based on reinforcement learning that has, it's not just that it has changed the way how we see the goal, but it also has revolutionized the chess and the new Chinese game, well, new to most of the Europeans. It's called shogi, and basically the same architecture, the same approach, different games, and it has shown its superiority across these different games. And you can see that on the chart. So the green line is the current best before this algorithm came out, and the blue line is how the AlphaZero has beaten the current state of the art, like the chess game or shogi game and so on. I met the guy who created Alpha, who was one of the creators of AlphaGo, which is David Silver. He's pretty cool. Another one from DeepMind called Alpha Star. This one is about StarCraft. So basically, they created the agent of playing StarCraft, and they have defeated one of the human experts. And why this is so close to my heart, because one of my friends, one of my students has been behind this algorithm. It's pretty cool to see how they solved such a difficult problem, as in you have to be in all the places at once, and then what are the locations where the deep learning is currently focusing, and all that kind of predicting actions and that kind of things. And it also has a score prediction, so it also predicts who is going to win, right? So it tries to predict the winning strike, whether it's winning or it's losing. Something that is closer to biology and medicine. So you guys probably know that one of the most difficult problems in biology is called protein folding problem. Is basically the idea is the following: we know the protein sequence, and proteins are not just strings of spaghetti flying around in cells. They are actually wrapping themselves up based on the sequence, right? And the way how they wrap themselves is very important, because it dictates the function of the protein. Because knowing the shape of the protein will tell us what exactly this protein can do in the body. But we don't know the shape, because shape is very hard to guess from the sequence itself. So alpha folding has been trying to predict the shape of the protein from a sequence, and that has been quite successful. Another something that I have done myself, it's retinopathy detection. So diabetic retinopathy is an eye disease that develops with the diabetes. So this is the sight of a normal person, and this is how a person with the retinopathy sees the world, right? They have trouble seeing the world because of the blood vessels in the retina being messed up. So if you look at the retina images, you can see that this is the retina of the normal person, and this is the retina of the person with a retinopathy, with a high degree retinopathy disease. And what we have been doing early on, and what people keep doing, is actually building algorithms that would predict the stage of the disease based on the retina image, right? So you can go to the doctor, you can look into some kind of mechanism, and they make a picture of your retina, and basically almost instantaneously you have a diagnosis, okay? Without doctor needing to spend half an hour looking at your retina scan to say if you have any signs of the disease. Something fun, like living portraits. I think I love that one. Basically making the portraits move. Fake or true faces, so generating very quite realistic pictures of human faces. Can you guys guess which one is real and which one is not? So the guy or the girl, who is real? Kenneth, who is real? The guy or the girl?
I feel like the man is real.
Man is real. Okay. Oleg, what do you think? Who's real and who's fake? Is it a man who's real or a girl who's real? Any clues? Any guesses? Simeon, what do you think? Igor, what do you think?
I completely disagree with Kenneth.
Okay,
Girl is real and man is fake.
Okay, okay, this is interesting. Oleg, whose side are you taking, Kenneth or Simon? Oleg, you're muted. I'm unmuting you. No, I can't unmute you.
Sorry. I think that man is real.
Man is real. Igor, whose side you're on?
I'm on some man's side.
Wow, we have
girl
half
is real,
and
I
half.
think.
The girl is real. Okay, so I must say that you guys, well, it doesn't matter, right? What's true or what's not true, because you already
Both
split
fakes,
in half.
yeah.
Lena, this is a surprise. So it's 3 a.m. at Toronto, and Lena joined our call. So you guys are not having a right to say that everybody is a man with a beard anymore, right? Because we have a girl on the call. Anyway, so she can break the tie. Lena, do you hear us?
Yep. Hi, Dmitry.
Hey,
Nice to hear
hey,
you.
do you remember which one
Hello.
is real and which one is not?
To be honest, not, but maybe I
Okay,
can.
so what do you think? Which face is real and which one is fake? We have a tie, so let me tell you that Igor and
Mhm.
Simon think that the girl is real. Kenneth and Oleg think that man is real. So whose side you're on?
Man is real.
Man is real. So now we have majority being wrong, right? Because the girl
Okay.
is real. So this is a tough one. I tried to look myself very deeply. You can actually find this link here, whichfaceisreal.com, and you can test yourself. I don't really have a good clue why exactly. I think I took this test a couple of times, and this was the pair of faces that I find the most confusing to me. So they're saying that the girl is real and the man is fake. And they're saying something about looking at ears and checking the ears, but I couldn't really see any problem with ears, to be honest. So
Her
so
hair looks fake in the bottom left. That's why I thought it wasn't it. The bottom
so
left
this
looks like,
one,
that looks like
this one,
art
right?
patch. Yeah.
Yeah, it did look, but at the same time, it looked also kind of real in a sense that there's a background light, so it's kind of fading with the background light. So, but I do understand. I also wouldn't recognize this one. Another cool domain expert is the chatbot, right? This was a very recent one, the Mina chatbot that they came up with this BERT type of networks, with NLP type of networks, and she's amazing. If you read the dialogue, she's like super useful. I mean, of course, this is a conversation 24, and if you go through conversation, all the 100 conversations, there are some things like weird things, but most of them look real, and she looks real. So it raises some moral questions about when do we judge a computer to be somebody whose rights we should be, kind of taking seriously. Yeah, so there is a link. I will send it to you later on, just to give you an example. Finally, the visionary slides are done. So thank you very much for staying up with that. Now we are getting back to business. So machine learning is divided traditionally in three major families, three major subfields. What are these subfields? Oleg, can you tell me what are these three major subfields that are machine learning is traditionally divided into?
Sorry, in parallel.
So machine learning is traditionally divided into three subfields.
You mean supervised learning, unsupervised learning,
and Simon, what do you think? Which one is the third one?
I think it is reinforcement.
Absolutely, it's a reinforcement learning. So supervised, unsupervised, and reinforcement learning. Good, very good. Now, if we look closely at each one of these, right? For example, we start with supervised learning. This is traditionally divided into two subfields. Kenneth, what are these two subfields that supervised learning is divided into? So supervised learning is also traditionally divided into two subfields, well, subfields, whatever. So which are?
Regression, classification.
Predictive and classification.
Yeah, so classification and regression. So we can divide it into two, classification and regression. Let's look at, just to repeat for ourselves, what's a classification. When you have, let's say, digits of one type, you have digits of the other type, they have different spelling, and then we have a new digit that comes in, and we have no idea whether this is one class or another class, because we previously knew that the other digits are of class 0, the second type of digits is a class 1, and then we have a new digit. We have no information about that digit, but the way this kind of ability to classify, to say which type of digit it is called classification. And this very specific type, Elena, is called, how do you call that very specific type when you have one and the other class? So just two classes, how do you call that?
binary classification.
You call it binary classification. You seem to operate at a high level of efficiency at 3 a.m. in Toronto. This is pretty cool. Thank you for joining. All right, so there is another type of problem called multi-class classification, right? So when you have more than 2 classes, in fact, 3 or more. So 3 or more is already called multi-class classification. You have 0s, 1s, 2s, and 3s. And then you have a new one, and then you have no idea what's the class. And predicting that class is called multi-class classification problem. All right, so this is classification. Here is a regression problem. The regression problem is dealing with continuous values, predicting not categories like 0, 1, or 2, and 3, but rather some value, some continuous value. For example, we are taking a taxi in the middle of Kiev, and we are going from KC to, I don't know, whatever, Chernigovska metro station. And sometimes it would take, so depending on the distance, depends on where we go, we can pay $5, $3.5, $7, and etc. And now when we take a taxi and we have all this history of the previous trips, previous rides, we can try to predict the price of the ride from, let's say, distance of the ride, right? And maybe a time of the ride. So if we take a taxi in the midnight, then it will cost us probably more than we take a taxi in the lunchtime, right? So all these things, it's predicting this continuous value is called a regression problem because we are not limiting ourselves with the discrete categories. We are actually predicting a continuous value. All right, so now my question to everybody, Igor, what is the main similarity and difference between these 2 classes of supervised learning? Okay, so we have classification and regression. What is the main difference? What is the main difference between these two classes?
Difference because classification has to provide us answers whether one object is 0 or maybe 1, yeah. And the second type of problems in terms of regressions, we have to like predict many outputs using like input variables.
Exactly. What's the similarity between these 2 things? So the difference is that the classification deals with the fixed categories, discrete categories, while the regression is dealing with infinite number of categories, right? The continuous valued. What is the similarity between these two classes? Kenneth, what is the similarity? What do you think is the similarity of these 2 families?
I mean, the process is the same right up until the final function, which makes the split between either the 2 or the multi-class.
Right. So it basically, the difference is, I mean, the similarity is that you basically deal with this labeled cases, right? You got tons of labels, you got tons of historical data, right? You had, in the case of regression, in the case of taxi rides, you had a lot of taxi rides that had been happening before. You knew the ride price, right? And in terms of classification, you had these labels for each of the digits. So it does, both of these deal with the labeled data, right? So each one of them labeled data. That's the main similarity between these 2 methods. That's why they are called supervised learning, because they deal with labels, they deal with the historical data. How about unsupervised learning? What do you think, guys? Oleg, what are the methods that come in somehow related to, associated with unsupervised learning?
The segmentation.
Anything else?
Segmentation, this clustering.
Clustering, okay.
Clustering.
Kenneth, do you know any other unsupervised learning method?
There's some computer vision stuff that's unsupervised.
So what, for example, which one?
Face recognizing, face not identifying, but face.
You know, like face identification or face recognition.
Face recognition. That's what I was trying to say.
Okay. Simon, what do you think? So what are the unsupervised learning methods?
But from clustering, I think it is also dimension reduction.
Dimensionality reduction, absolutely,
Yes.
absolutely. Okay, so what you guys saying, I have to make a comment here. So segmentation is a supervised learning, because segmentation is basically a per pixel binary classification or multi-class classification. So for each pixel on the image, you make a prediction about the class. It could be, let's say if I'm talking about myself, right, then I have a image of the road, and then I have a pedestrian on that road. So my segmentation methods would be interested in saying which pixels of this image belong to pedestrian class, right? So what I essentially do is I do this per pixel binary classification saying road, pedestrian, road, pedestrian. It's a supervised learning problem because it has a labels. It has usually this manually annotated label that is used for training. So this is supervised learning. Kenneth, what you were saying, the face recognition is also supervised learning because you also have a labeled data, right? So you had the historical data, this face belongs to Dima and that face belongs to Kenneth. We have seen that faces. And then we built this convolutional neural networks to predict the face, kind of match the face and the person, right? So this is, it's also supervised learning. What unsupervised learning is what Oleg once said, one of these things that you said, Oleg, was clustering, because it does not have label data, because it just looks for the hidden structure. And what Simon said, which is dimensionality reduction, because it doesn't have the label data. So let me show you this. So dimensionality reduction is when you have something super high dimensional, like this torus here. This is a high dimensional torus. And what happens is that you project that torus, which is in a super high dimensional space, into low dimensional representation. For example, in the case of this torus, you can get two circles, one inside the other. And basically this is a low representation of a high dimensional space, right? So this is what dimensionality reduction, PCA, is one of the dimensionality reduction methods. I believe that Roman Ko told you about PCA. I'm not sure how much details you know about PCA. So one of my questions was, do you guys want to know about PCA more? Because I have a lecture about unsupervised learning, and this was one of my kind of key concerns, that I'm missing that part. But we're going to discuss that a bit later during this lecture. Maybe I'll ask you at the end of the lecture. I'll still kind of interested in your opinion. And of course, clustering is another type of unsupervised learning methods. So you got a bunch of objects, and you don't know the classes of these objects, right? You have no prior expectation, you have no prior information about what kind of objects you have. Since you guys are mostly business people here, you can think of your company business selling stuff to your customers. You have no prior information about which customer is this kind of high spender customer, because they don't have tags. They don't wear tags saying, hey, my name is Dima and I'm high spender, right? It doesn't say that. It doesn't say I'm Dima and I'm really, I'm having problems with my money, so I don't want to spend too much time and too much money on your product. This is something that you will have to, find out yourself. And this is what unlabeled data looks like. So you have tons of customers and you have no idea which families of customers they come from. And what happens is that you try to figure out what are the hidden structure inside of your data. So which are the high spenders and which are the middle spenders, and so on and so forth. So this is what clustering is about. So this unsupervised lecture that I have has PCA and different clustering algorithms. And I'll ask your opinion whether you want to have that one instead of regularization methods. So this is unsupervised and supervised learning methods. I have a question here. What is the main similarity difference between classification and clustering? Igor, could you tell me, what do you think is the main difference and similarity between classification and clustering?
Well, in classification, we definitely know the likely outputs, 0 or 1, or even something else, maybe. With clustering, we don't know. We don't know the right outputs. We can't predict actually how many clusters do we have. What kind
Exactly.
of
exactly. Exactly. And what you were saying, so in classification, we have a prior information. We had tons of digits that have been labeled by somebody, and we are going to talk about that. In clustering, we have no prior information. We didn't know what kind of clusters there are. We didn't know how many clusters there are. We didn't know what are the semantics of each of the clusters. So that's the main difference between these two. What is the main similarity? Oleg, what is the main similarity between these two families?
The main similarity that in principle we let's say in both cases, let's say sort data by baskets. Yeah, so
exactly. We come up with the discrete categories, right? Yeah. In the terms of classification, we can say this is type 0, this is type 1. In terms of clustering, we can say, well, this is one basket, this is basket number 2, this is basket number 3, or this is cluster number 4, right? So these are discrete categories that we build up in the clustering without knowing how many categories there are and what they consist of, okay? Do you guys have your own questions? Ask me your own questions, or is it easy peasy lemon squeezy, nothing to write home about? Because I can see from your questions that you still have questions about these kind of things. It's not exactly crystal clear. So if you have questions, please go ahead.
I think this dimensity reduction we didn't cover too much. Oh, please, guys, correct me if I'm wrong. Yes, somehow it was.
I was told that you were mentioned that there is a PCA that it exists, but you were told more about clustering methods rather than dimensionality reduction.
Yeah, maybe it was mentioned, but to be honest, it somehow is not in my mind. Yeah.
I think I think we saw that slide, and that's about it. I think we saw the exact slide you showed, and not much more.
Okay, gotcha. But so I really want to understand what's the best fit for your backgrounds and what's the best lecture that I can give you, second lecture. This is the only kind of flexibility that we have. I can give you unsupervised learning lecture instead of regularization methods, but we'll see. So the last family is reinforcement learning.
I think so far, classification, regression, clustering, I can imagine a practical use. Dimensionality reduction, I don't have a practical use that kind of jumps into my head.
Gotcha.
The same for me. The same for me. Yeah. How we can
what's the use of it? Right? What's the importance of
business use cases? Yeah, business use cases.
Who uses this?
I cannot tell you for everybody who is using that, but I use it quite heavily. So imagine yourself, you have tons of data, and these data is not necessarily very representative data. For example, your business is dealing with some kind of communication protocols, and you got tons of this kind of technical features in your data set, some kind of wave functions, whatever there is in this kind of something abstract that you don't really understand. But the problem is there are so many of these features that when you train a machine learning algorithm, they start to suffer from something called dimensionality, curse of dimensionality. It's when the dimensionality of the space is so vast that it actually starts to influence your performance of your classification algorithm. So what happens instead, you compress that space. You compress these features into very few features that make sense, that starts to explain the problem, that, for example, divide your instances into classes. And then it makes the life for supervised learning algorithms that you use on top of this method very, very feasible. It makes sense for the supervised learning algorithms to see the classes. And I have an entire lecture and practice session about this. Let's say that I'm happy to give you unsupervised learning instead. All right. Let's just finish this lecture and then see which one comes up top in your priority list. But I understood that you're interested in this area, and maybe we should cover that one. So let's just continue with the flow. It's a reinforcement learning. Basically, the idea is that you have an agent, the brain here, It could be artificial, so it doesn't have to be biological brain, but it's us, each one of us is an agent. And we are driven by action reward type of relationship with the world, right? The world gives us a reward and we produce action. And in this very specific case, there is an agent that is trying to learn to play breakout game, right? So what they do, the agent has only two possibilities. They can either stay at the same place, or three possibilities. You can either stay at the same place, you can move left, you can move right, in order to increase the score and not lose your lives, right? This life stuff. So this is the reward, how many bricks that you broke. And then the agent is trying to learn the optimal strategy to act upon the reward, okay? So this is what reinforcement learning is about. We're not going to look inside the reinforcement learning because you already had reinforcement learning for once. And then secondly, there is a very good link that explains how .rl works. If you go to this link, you will know my motivation to not give you a reinforcement learning a part of the lecture. So please open up, try it up, how .rl works. That's all you need to type into your browser, how .rl works. Old good joke by engineers. It doesn't really. That's all there is for the reinforcement learning. That's why we're not really studying it so far. Yeah, and it's not my joke because I'm not doing reinforcement learning, but I'm hoping that maybe I can try it someday. We actually, in this part of the lecture, we will focus on classification problems, okay? There will be also regression problem that will come a bit later, but so far we are focusing on classification problem. We will have a break in 14 minutes, so you can stretch your legs and you can get some tea or walk around the couch if you are in the house. Then, because we need some fresh minds. We need fresh minds and we need some power in your brain. So what are we going to look at is the classification problem. We are having one class of things as zeros, the other class of things as one, and then we have a new digit that comes around. And what we can do instead of looking at these digits, we can, for example, position them with respect to the height of the digit, right? So we can look and build this kind of axis along which the digits get higher and higher and higher. So at the left side, the digits are the smallest digits. At the right side, they are extremely large. And then we plot this new digit, so we can measure the height of this new digit, and we could position it with respect to other digits in our database, right? So this is the digits that we have here are the database. This is our database. This is what we have seen so far. The new digit comes along. We don't know where it is or which type it is, but what we can do, we can measure its height. And then we can compare that height to all the digits that we already had in the database. Now, we look at these database and the new digits with respect to the old digits, and we can think of what is the class of that digit. Is it a 0 or is it a 1? Simeon, what do you think? Is it a 0 or 1? Depending, well, looking at this visualization, what do you think? Is it a 0 or 1?
With high probability, this is 0, I think.
Why do you think so? This is a very good, I think, way of reasoning. Why do you think so? Why it's highly likely that it's 0?
I see that one few digits they are mainly on the right part of the curve, and on the left part mainly zeros. Yeah,
exactly. So that's a very natural way of thinking. So since there are more zeros around this question mark, that might be that's probably 0, right? So so we would be forced to decide. We would look at this left side, as Simone is saying, and we would consider that to be 0 because there are so many zeros around it, right? Now we can add a little bit more dimensions, and we can say that instead of just measuring height, we can also measure width of the digits, right? And then we can position them with respect to height and width of each of the digits, okay? this is how the classification in principle is defined. We use our our previously recorded data. So this is our previously recorded data. However it came to be in our database, we use that data to predict a class of the newly arrived example, right? So we use that historical data to see what is the class of the new data point. And here we're going to discuss a very simple algorithm that I'm pretty sure you have learned so far. It's called nearest neighbor algorithm, or nearest neighbor classifier, which is basically infers the class of a newly added example from the class of the nearest neighbor. So you got all the history data, and then you find the closest, the nearest example to your new data point, and then you infer the class. Okay, so in this case, the closest neighbor was 1, so we infer the class 1. We find the nearest neighbor by calculating distances to all neighbors in the data set. Okay, all the neighbors. So we try to find out what is the nearest neighbor, but there is no better way to find out what's the nearest neighbor besides calculating distances to all possible neighbors. So let's just come from this, let's transfer from this kind of digital representation to more like a dots. So we have a red dot representing zeros and blue square representing ones, and the dark dot is representing the question mark. We don't know what this dot stands for. So what we do, we calculate the distance, right? We calculate distance to every example. And the way how we do it, we use the basically Euclidean space. Since we are in Euclidean space to some extent, we have these coordinates x, y, and y1, x2, and y2. Kenneth, could you tell me please what x value of this point? What is the x1 value of this dark point here? I can't hear you, sorry.
Yeah, 3, 3.
So yeah, the coordinate of this point is 3, 3. So the first coordinate represents height. The second coordinate represents width, right? And the same happens with the blue one, which is basically 2, 3, right? Oleg, can you tell me what's the distance between these 2 points? We can't hear you again, the muted.
Oh, distance between these 2 points, 1.
I wanted you to ask me what kind of distance are we looking for, right? Because there are plenty of different distances. I can ask you what is the Euclidean distance, right? And then you would be right saying this is 1. Because if we look at the Euclidean distance, this is how you calculate the Euclidean distance. It's subtracting one coordinate from the other squared plus the other difference squared. So if you calculate this 2/3, 3, 3, and this is basically 1. So that's clear here. Then we calculate this distance for all the other points in the data set, right? So from the newly arrived example to all the points in our data set, and we choose the smallest, right? So we inferred the class from the smallest. We saw that blue square, fine. Now, there is a caveat. We can use, it turns out that using one neighbor may not be the best strategy ever. So instead of using one neighbor class, we can use k neighbor classes, right? So this is now called k nearest neighbor. So k nearest neighbor here. So instead of inferring the class from the nearest neighbor, we can infer the class from k nearest neighbors. Let's consider k to be 5 in this example. Lena, what would be the class of the point based on this example and k equals 5?
Good question. 1. Oh, sorry, 0.
Oh, just tell me a color. Just go with the color.
Red one.
So it would be the red one. Simon, why this point would be a red one if we consider 5 and k nearest neighbor for this point?
Because 3 is more than 2.
Yes, exactly. 3 is more than 2. Absolutely. So this is an example of this very simple questions that I'm asking sometimes, and people are like, why is this asking that kind of stupid questions? It's clear, right? This is red, right? But now, Igor, you don't have cameras, so I'm asking people that are in top of my list which have cameras. So Igor, could you please tell me what happens if we say that K equals all the points in the database? What would be the class of the newly arrived example if we use K equals all the points? You're muted, I guess.
Oh, sorry. Well, if we have K elements and we will obtain K classes, it means that each element is like separate class, but no commonality between elements.
No. So let me rephrase it a little bit. Okay. So we just used K equals 5, which means that for this newly arrived example, we consulted 5 nearest neighbors. So out of these 5 nearest neighbors, 3 were red and 2 were blue. So Simeon said that 3 is more than 2. I trust Simeon on that. I don't think myself that this is true, but I trust him. And he said 3 is more than 2. And then it turns out that since there are 3 red classes and 2 blue classes, this point became red point, right? Because there are more red classes than blue classes. And now my question is, what if K equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11? What class the black point would be if K equals 11?
Well, 3, 5, blue. I think blue.
It would be blue, of course, because the majority is blue, right? So if you would say that everybody is participating in the vote, then that would be blue. Yeah. All right. So this is the K nearest neighbor. What happens if we have more than 2 classes? What happens if we have more classes? You can think of this as, the example was digits. So we have 7s and 9s besides 0 and 1. So these are green triangles and yellow diamonds. And we now have a newly arrived point here. And now we use K equals 5. Kenneth, what would be the class of this point if we would use K equals 5 and K nearest neighbor?
Looks like yellow.
It would be yellow because there are 2 diamonds, 1 blue square, 1 green triangle, and 1 red circle. So that would be yellow because it would win the vote. Okay. How can we use a KNN? And this is the last thing before we go for a break. KNN for regression. For example, we are trying to predict height from width. So we are trying to infer the width of the digits from its height. Okay. Now we use KNN and K equals 5, and so we end up having these 5 neighbors, but which have width. So these are height. So these are their height. And what happens is that we take the average of these 5 and we infer the new height. The prediction would be 5.8 because it would be the average of the neighbors. So in order to use KNN for regression, you just basically average up the continuous values of the neighbors, right? Do you guys have questions before we move on to code?
I have only one question about the this example when we defined the cluster based on all 11 points. Here we classify it as blue just because majority of points are blue.
Yeah, that's called majority class prediction.
Majority class. Okay. Okay. Thank you.
Yes. So since K
no weighting of distances happened.
Yeah, in this case, no weighting of distances happened. It's actually a good comment from Kenneth because you can actually use distances as one of the ways to decide whether you should trust the blue class or the red class. Since the red class on average seems to be closer than the blue class, you could have decided that this is a red class just based on the distances. But in fact, in this case, we just were saying blue or red. This was a very binary decision. Any other questions so far? So we are not now having a break. We're going to have a break, but you can, I'm happy to answer questions. If no more questions until the break, let's have a 10-minute break until 10:30, and let's come back to K nearest neighbor and actual Python code.
Okay.
Okay.
Okay, see you later.
Yeah, go ahead and stretch your legs, and I'll be here, but you go and have break.